Good afternoon to all. Am I audible? Can you please message me in the chat? Can you mention in the chat? Am I audible? Am I audible? Yes. Okay then. Okay, I will start the class. Let us see what is meant by an average value. So average means so here we are discussing about AC circuits, therefore alternating quantities. So if I want to determine the average value of an alternating quantity, then it is defined as the arithmetic mean of all the values over a one complete cycle. So for that, let us see this. So you can see this is an alternating quantity which is a sine wave. Okay, you can see here it is written sinusoidal wave. Is my audio matching with the display? Is my audio matching with the display of an alternate? Okay then. So here you can see a sinusoidal waveform. So it's a one cycle, isn't it? One positive half cycle and one negative half cycle is here. So it is one complete cycle. So in one complete cycle, if you consider the arithmetic mean of all the values in this one complete cycle, then that is the average value of this alternating quantity. Now to understand it more clearly, let us see this waveform. In this waveform, if you see here, I have taken, see it's a symmetrical waveform, we can say, because positive half cycle and negative half cycle, it will be symmetrical to one another. Okay, therefore I have considered only positive half cycle here. So if you see, I have divided this positive half cycle into n parts. You can see from 0 to this one section, section 1, section 2, section 3, section 4, section 5 and so on up to n. I have divided into n pieces, I can say. This half cycle has been divided into n parts. So at each instant, at instant 1, at this instant 1, let us assume this is a current waveform. You can consider current or voltage. Okay, so the alternating quantity shape will be same for both current or voltage when it is sinusoidal or maybe any waveform. Okay, so the shape will be same. So here at instant 1, current, let us assume it is I1. At instant 1, current is I1. I will just zoom it. Okay, at instant 1, current is I1. At instant 2, current is I2. And at instant 3, current is I3. At instant 4, current I4. At instant 5, current I5 and so on up to at instant n, current is IN. Okay, at instant n, current is IN. So we have divided this half cycle into n parts and at each part instantaneous current, at that particular instant how much is the current, those current notations have been given here. Of course all the notations are not mentioned, only 4 notations we have mentioned here. In between it is understood. Okay, so if you take an half cycle of the given waveform, alternating quantity we can say. So if you take a half cycle here, this is positive half cycle, you divide it into n parts. Okay, then simply if I want the average value of this alternating quantity, simply add all the instantaneous values I1, I2, I3, I4, I5, I6 and so on up to In. You just add it and divide it by number of times it has been divided, means n number of times this waveform has been divided into n parts. Therefore divided by n number, you will get the average value, which is well known to you people, isn't it? So just write it down, average value, and note down these 3 lines. Okay, one more thing that we must keep in our mind is that since alternating waveform is symmetrical in nature, okay, since it is symmetrical in nature, okay, whether it is a sine waveform or sawtooth, square waveform or triangular waveform, whatever may be the waveform, if it is symmetrical in nature, then the average value of one complete cycle means it consists of one positive half cycle and one negative half cycle, the average value will be always equal to 0 because of symmetry. Okay, because of symmetry, the average value of one complete cycle will be always equal to 0. Therefore whenever you want to calculate the average value, you must consider only half cycle. Okay, so okay, now let us see the average value of an alternating quantity. Average value of an alternating quantity. Okay then. This is it. Average value of an alternating quantity, which is sine wave here. I am considering a sine wave here. So I want to determine the average value of this sine wave, and since this sine wave is symmetrical in nature, instead of considering one complete cycle, I am going to consider only half cycle. Okay, because of its symmetry. So as I said, simply if you divide it into n parts, n number of parts, half cycle, if you divide it into n parts, then the average value you can calculate by this formula. I average is equal to I1 plus I2 plus I3 up to In whole divided by n. You can calculate by this formula. Okay, so now I want to determine the average value of this sine waveform without dividing it into n parts. Okay, so I can't consider the total cycle, one complete cycle here, because of symmetry. As I have already told you, the average value of one complete cycle will be always equal to 0. Therefore I will consider only half cycle. So what is the length of this half cycle? Length of the half cycle is 0 to pi. This is pi. Okay, I can zoom it. I will zoom it so that it will be more clearly visible. So length of the half cycle is 0 to pi. So, and we know, let us assume the sine wave, the alternating voltage, sine wave voltage is given by V equal to Vm sin theta. If the alternating voltage of this sine wave is given by V equal to Vm sin theta, then the average value for half cycle is given by 1 by pi 0 to pi V d theta. Okay, average voltage of this this voltage waveform. If I want to determine the average of this alternating voltage, simply V average is given by V average is equal to 1 by pi 0 to pi V d theta. Okay, so what is V? V is Vm sin theta. So instead of V, substitute Vm sin theta. So instead of V, if you substitute Vm sin theta, you will get 1 by pi 0 to integral of 0 to pi Vm sin theta. Vm is what? Vm is the maximum value. So you see here, Vm means it is the peak value at total half cycle is 0 to pi. Half of the half cycle is what? Pi by 2. At pi by 2, whatever voltage that you get. Here I have written Vp. So as you already know, Vp means peak voltage. Vm means also maximum voltage. Peak voltage or maximum voltage are same. Okay. So Vm sin theta. Instead of Vm, I can write Vp. It doesn't matter. So Vm sin theta. Vm maximum value is a constant value. Therefore, you can keep Vm aside. So you will get Vm by pi integral of 0 to pi sin theta d theta. Okay. So average voltage formula is what? Vm by pi 0 to pi sin theta d theta, where the limits are from 0 to pi. So now you can simplify this simplify this integral part. If you simplify that integral part, just note down. As I vary the slides, you can note it down. All of you can note it down in your notes. Okay. Now just simplify that integral. You will get minus cos theta. Limits are 0 to pi. Just substitute those limits here. You will get Vm by pi and 1 plus 1. So 2 Vm by pi. So what is the average voltage for a sinusoidal waveform? It is 2 Vm by pi. So you can represent it on the waveform. Okay, 2 by pi, you can just solve it and you will get 0.637. Okay, 2 by pi is 0.637 Vm. So on the sine wave, so if this is Vm, I will just expand it and I will write Vm instead of Vp. So this is Vm. Okay. So Vrms is what? Vrms, we have already discussed. Vrms is 0.707 times of Vm. Okay, and V average, just now we have seen, V average is 0.637 times of Vm. So if Vm is equal to 1, okay, if Vm is equal to 1, that means Vrms is 0.7 times of Vm. This is Vm. V average is 0.63 times of Vm. Okay, so 0.707 means it is 70% of the maximum value Vrms. Vrms, which we have already discussed. V average is 63% of the maximum value. Okay. So now let us see what is meant by form factor. So what is meant by form factor? So form factor, it is the ratio of RMS value by average value. What is RMS value? It is 0.707 times of Vm. What is average value? It is 0.637 times of Vm. So Vm cancel. What is form factor? Form factor is a constant which is given by 1.11. Okay, form factor is constant which is given by 1.11. So it is always constant. So just note it down. Form factor definition and its formulae. So form factor is always 1.11. Is my screen visible? Screen is black. Okay. Is it visible now? Is it visible now? Okay then. Crest factor. So crest factor is the ratio of maximum value by the RMS value, whether it is voltage or current, irrespective of that, whatever may be sinusoidal waveform, voltage waveform or current waveform. Crest factor is given by Vm by Vrms. So Vm is the maximum value by RMS value. So you just write down Vm. What is Vrms? There is a relation between Vrms and Vm. What is the relation? Vrms is 0.707 times of Vm. So Vm cancel, crest factor you will get 1.414. Crest factor is 1.414. So you can see different waveforms here. So just note down the crest factor. Note down the crest factor. It is the ratio of maximum value to the RMS value of an alternating quantity. It is the ratio of maximum value to the RMS value of an alternating quantity. So crest factor, note it down. So crest factor value is 1.414, whereas form factor value is 1.111. Okay, now you can see here different waveforms: sine wave, square wave and triangular wave. RMS value of sine wave is what? 0.707 times of the maximum value, that is peak value. For square wave, RMS value will be equal to peak value, and for triangular wave RMS value is equal to 0.577 times of the peak value. So in we are discussing only about sinusoidal waveform, so no need to compare the sinusoidal waveform with the other waveforms. Okay, just leave it, just for in order just to give some information regarding other waveforms I am showing it here. Okay, so let us solve a numerical problem. Let us solve a numerical problem. Okay, so an alternating current takes 3.375 milliseconds. Okay, so some time is given in milliseconds here. This time is 3.375 milliseconds, and this time was taken by the alternating current to reach 15 amperes. Okay, in order to reach 15 amperes current, the time taken by the alternating current is around 3.375 milliseconds for the first time after becoming instantaneous zero. Okay, after crossing the 0 point on the waveform, okay, on the x-axis I can say, after crossing the 0 point on the x-axis, it took around 3.375 milliseconds for the alternating current to reach 15 amperes. So the frequency of the current is 40 hertz. Okay, the frequency of the current is 40 hertz. Frequency is given. You have to find the maximum value of the alternating current. So simply some current value is given, 15 amperes. The time taken to reach this current is given, that is 3.375 milliseconds. Frequency of 40 hertz is given, and they didn't mention whether the waveform, this alternating quantity, of course they have mentioned it is current, but they didn't mention whether it is sine wave or any other waveform. Since it is not mentioned, let us assume it is a sine wave. Let us assume it is a sine wave. So let us assume it is a sine wave, and let us assume, therefore for a sine wave we know current equation of sine wave, I is equal to Im sin theta. So I is equal to Im sin theta, and they have asked us to find the maximum value. We don't know the maximum value, so simply you just, instead of sin theta, you can rewrite theta, replace theta by omega t. Omega means what? 2 pi f. Okay, omega means 2 pi f. So I value, some current they have mentioned, that is 15 amperes. I is 15 amperes, Im we don't know, 2 is constant, pi is constant, and F is 40. T to reach 15 amperes current, time taken is around 3.375 milliseconds. So milli means 10 power minus 3. So I have mentioned that 10 power minus 3 here. Okay, so you just solve the sine term here, the whole sine term. If you solve, you will get 0.75. So 15 equal to Im into 0.75. So Im is equal to 20 amperes. So maximum value of current is 20 amperes for this given numerical problem. Just note it down. So J operator, let us see what is meant by J operator. So if you take x axis, you can see here, this is x axis. I have considered voltage. Okay, I have considered voltage E. I have drawn a vector E here. So I am drawing a vector here. This is my voltage vector, or I can write V. It is more convenient to understand, isn't it? Now if I take E, V voltage, and if I represent it in terms of vector, okay, I have drawn a vector. This is my V voltage, which is in which I have represented in vector form. Okay, in anti-clockwise, if I rotate it in anti-clockwise by 90 degree, okay, if in anti-clockwise if I rotate it by 90 degree, then this V will become JV. This V will become JV. Okay, this V will become JV. Okay, so what is on the real axis? This is 90 degree angle. So what is on the real axis? Voltage, and it has become imaginary value. J means imaginary value. It becomes an means it will be multiplied with some operator which is known as J. Okay, we can call it as imaginary. Y axis you can call it as imaginary axis. This is x axis and this is y axis. So the V will be multiplied with some operator J if it is